Hi students, this is Ms. Cave and this is our foldable on writing and solving proportions. So you should have received this nifty little foldable in class today. So you have on one side writing and solving proportions, and what we're going to do is we're going to go inside the foldable and start looking at the examples. So first we're going to go underneath writing proportions. And for the first part, we're going to be able to show and tell whether the ratios are proportional. So remember, as we're going through the video, make sure that you're marking your notes just as I'm marking them and adding any other notes for yourself that you think that you need. Okay, so let's go ahead and get started. First of all, we have ratios, and we're trying to figure out whether we're proportional. And if they're proportional, that means that the ratios have the same relationship. And we talked about proportions in class, so that the ratios have the same relationship. And there's several ways that we can do that. We can look at the relationship horizontally, we can look at it vertically, and we can also look at the relationship diagonally. So what do I mean by that? Well, let's take a look at the first example. So the first example, 8/9 is equal to 40 over 45. So for this one, I'm going to look for a horizontal relationship because I can see 8 and 40, 9 and 45. So I'm looking for that horizontal relationship, and I can see that both of them have a times 5 relationship because there's 5 times as many 8s. 8 times 5 is 40, and there's 5 times as many 9s to get 45. So this is proportional, and I can prove it this way. Let's take a look at number 2. Number 2, if I try to look horizontally, it's a little more difficult because the numbers don't go in evenly. So let's try looking at, now we're going to look at a vertical relationship. So we're going to look at the numbers vertically and see if there's a relationship. So I'm going to look at 4 and 12. And I notice that the relationship between 4 and 12, 4 goes into 12 3 times, so this is a times 3. And then I'm going to look at 7 and 20 and see if it's the same relationship. Well, 7 doesn't go into 20 3 times, it goes into it less than 3 times. So because they don't have the same relationship, it's not a times 3, so this is not the same relationships. This is going to be a no. It's not a proportion. All right, let's look at number 3. We have a word problem. A particular shade of pain, oh no, that's no good. A particular shade of paint is made by mixing 2 parts red paint and 5 parts blue paint. To make this shade, Jackson mixed 7 quarts of red paint and 17.5 quarts of blue paint. Did he mix the correct shade? So when we're mixing paint, to get it to be the same color, we need the ratio here of red and blue to be the same. So we need to check out that ratio. We have 2 parts red and we have 5 parts blue. So that's going to be our one part of our ratio. So we're going to have 2 to 5, and this is our red, and this is our blue. And we're going to find out if the ratio in what Jackson created is the same. So now we have 7 quarts red and 17.5 quarts blue. So the red, I'm going to keep on top with the red, the 7, and the 17.5 blue. All right, now for this problem, again, we're going to look for relationships, 2 and 7, 5 and 17.5. So I could look for these relationships that way. I could look for a horizontal, and I know that 2 times 3.5 is equal to 7. And I'm going to check to see if 5 times 3.5 is 17.5. If that relationship is the same, I can conclude that the paint would be the correct shade. So 5 times 3.5, 5 times 3 is 15. 5 times 0.5 is 2.5. I'm just breaking this down. 15 plus 2.5, yep, it's the same relationship. 5 times 3.5 is 7.5. So yes, he did. The answer is yes. Because the original paint, the 2 to 5 is equivalent to 7 over 17.5. Let's look at some examples now that we know how to tell whether ratios are proportional. We're going to look and solve for x. So what if we have a missing number? All right, so for number 4, we have 3/9 is equal to 5 over some number. So again, I'm looking for relationships. So I see this relationship here, 3 and 9. 3 times 9, or excuse me, 3 times 3 is 9. So I'm going to apply that same relationship here, and I get x is equal to 15 because it's the same relationship. We know these are proportional. We have the equal sign, so we know they're proportional. Now we need to just figure out the missing number. All right, our second one. Let's see. I'm looking for relationships between 2 and -5. And I know it's 2.5, but we're going to look at another strategy here. And let's see. So for this one, I'm going to use something called a diagonal relationship. What I know is that when I have a proportion, that their cross products are going to be equivalent. So I know that 6 times 2 is 12. And then the cross product on this side, I don't know what the product is, but I know how I get it. It's -5x. So I know that 12 is going to be equal to -5x, and I'm just going to move this down here. 12 is equal to -5x. So if the diagonal relationship means they both have the same cross product. So if this is 12, x times -5 must also be 12. So now I'm going to simply solve for x. So I'm trying to figure out -5 times what number is equal to 12. In order to solve this, I'm going to divide both sides by -5. And then x is equal to 5 goes into 12 twice. And I have 2/5 left. And I have a positive divided by a negative, so it's a negative. So my answer is -2 and 2/5. All right, number 6. Again, we're looking for a relationship. I don't see how -4 goes into 7 evenly or -4 goes into 9 evenly. So I'm going to try that same method again. This is our diagonal relationship. Our cross products are the same. That's a way that we can find the missing value. So my first cross product here, I don't know my value for x, so the cross product is -4x. And then I know that that's going to be equal to 9 times 7, which is 63. And to solve for x, I know -4 times some number is equal to 63. So I have an equation now, so I'm going to divide both sides by -4. All right, and so 4 goes into 60 15 times. Four goes into 60, and it's going to be negative 15 times. And then I have 3/4 remaining. Because 15 times 4 is 60, I have 3 pieces left. My answer is going to be -15 and 3/4. And right now we're still not using our calculators. We're still using operations with fractions to solve these problems. All right, number 7. 10 over x is equal to 52 over 13. All right, so for this one, I could use my cross products, but I see a relationship here. I know that 53 divided by 4 is equal to 13. So for this one, I'm simply going to take 10 and divide it by 4. Again, I have that vertical relationship, 10 divided by 4. So 10 divided by 4 is going to be equal to 4 goes into 10 twice. I have 2/4 remaining, and I'm going to simplify that fraction to 2 1/2. So as you can see, we have different ways of solving proportions, and you have those examples here. And now we're going to apply this more in some word problems. So the next part of the foldable is you're going to write proportions for each situation, and then you're going to solve them. So number 1, the ratio of teachers to students at the middle school is 1 to 12. If there are 1,080 students at the school, how many teachers are there? So we've got our original ratio 1 to 12, and we know this ratio is teachers to students. So what I'm going to do for this, just to make sure I keep my information lined up, is I'm going to put this in a box like so. I'm going to make my proportion using this box, and I have teachers on top, students on the bottom. And I know from the problem, the ratio of teachers to students at the middle school is 1 teacher for every 12 students. And it says if there are 1,080 students. So I've got to figure out whether that number goes on the top or the bottom. And if I've organized my information, I know that students should go on the bottom, 1,080. And then my unknown value is here. All right, so I have my proportion. 1 over 12 is equal to x over 1,080. All right, now for these, I want you to go, now that we have our word problem here, I want you to go ahead and work on this one. I want you to use whatever method you want, but you may use a calculator for this one because we're getting into some bigger numbers. So go ahead and pause the video and solve for x, then unpause and see how you did. All right, let's see how you did. I'm looking for a relationship between numbers. So I know that 1 times 12 is 12. So I'm looking for what number times 12 gives me 1,080. So to figure this out, I'm going to take 1,080. To go backwards, I know the inverse of multiplying by 12 is to divide by 12. And I'm going to take 1,080 and divide by 12. And for this one, you can use a calculator. And when I do that, I get 90. So x is equal to 90, and x is equal to 90 teachers. All right, number 2. Let's go ahead, pause the video and try setting this one up, but I want you to make your grid here. And you have gallons, your 2 units are gallons and pounds. So set up your proportion in the grid and then write and solve your proportion, and then you can restart the video. Okay, let's look at how you did. 4 gallons of gasoline weigh 25 pounds. And then how much does 15 gallons of gasoline weigh? So now I've kind of organized my information using the highlighter. So gallons is going to go here. I have 4 gallons, and that weighs 25 pounds. And so how much does 15 gallons of gasoline weigh? I'm going to put 15 here. And then I don't know its weight. Oh, excuse me. Messed that up. Okay, so it's gallons to pounds, so I know gallons, so the 15 actually goes on top. And I'm trying to figure out its weight. See how easy it is to mix that up. So now I have my proportion. 4 over 25 equals 15 over x. I'm looking for relationships here, not as easy to see, so I'm going to use that diagonal relationship, and I'm going to use my cross products. So I'm going to circle my cross products here so that I'm careful. So 4 times x is 4x. And then I'm going to multiply 25 times 15 on my calculator. And I get 375. And I'm trying to figure out 4 times what number is 375. So I'm going to have to divide this by 4, but it's an equation, so we do the same thing to both sides. If I divide 375 by 4, I get 93.75, and then my answer is in pounds. All right. A couple more problems to try. Number 3 and number 4. Number 3, on a certain day, the exchange rate was 100 US dollars for 74 euros. How many US dollars were 481 euros that day? So again, I'm going to make my proportion box here so I can organize my information. And my 2 units that I have are dollars and euros. So I have dollars on top and euros on the bottom. So go ahead and stop the video and set up and solve your proportion, and then restart it when you're ready to check your answer. All right. So from the problem, I know that it's $100 right here and 74 euros. And then it's asking me how many US dollars, so I don't know. I'm going to use my variable, were 481 euros. So my proportion is going to be 100 over 74 is equal to x over 481. For this, we're going to want to use our diagonal relationship and our cross product. So I'm going to multiply 100 times 481. I don't need a calculator for that when I'm multiplying by 100. I'm just going to move my decimal point over 2 places. So it's 481, 20. So this is 48,100 is equal to 74x. To figure out x, 74 times something is equal to 48,100. I'm going to divide both sides by 74. And now I can get my solution. 48,100 divided by 74 is going to be equal to 650. And how many dollars? That's $650. All right, last problem, number 4. Go ahead and pause the video and set this one up and solve it yourself. And then restart the video and see how you did. Okay. Number 4, the Photoshop can develop 1,024 photos in 8 hours. At this rate, how long will it take to develop 160 photos? So we have our 2 units. We have photos. And we have hours. So photos and hours. So we know that it's 1,024 photos, our original ratio, in 8 hours. And at this rate, how long will it take to have 160? So I'm keeping the photos with the photos. So 160 photos. So this is going to go on top. And what I don't know is the time. So that's my variable. I have my proportion here, so I'm going to rewrite it over here. 1,024 over 8 is equal to 160 over x. You could use cross products for this. You could also look at to see if there is a vertical relationship. Either way, I'm going to go ahead and do that for this one. I know there's a relationship between 1,024 and 8. So I'm going to see what I do to 1,024 to get 8, and I'm going to use my calculator. 1,024 divided by 8 is, okay, 128. So this is a division by 128. That's my relationship. 8 is 1/28 of 1024. So I'm going to do the same thing over here. I'm going to divide this by 128. I'm going to do that on my calculator. 160 divided by 128. And I get 1.25. Oops, not 24. 1 1/4 hours. And that is my answer. And you may have done the cross products, the diagonal relationship for that one, but I was showing you another way that you can look for those relationships. Okay, that's it for solving and writing proportions. Have a great day.